So in this regard, we have a madam, respected madam, Ms. Vrinda M. Desai, Textile Commissioner, Ministry of Textile, our esteemed chair for today's session, distinguished panelists, representative from the government, industry development partner, financial institution, academic, and ladies and gentlemen. It is a great honor to participate in the Bharat Text. I think Bharat Text is the platform which we need to think about how we will try to come together and look for some solutions, especially for the textile sectors. At the outset, I would like to express my sincere gratitude to Ms. Vinda Madam for graciously accepting our invitations to share the important sessions, her leadership and continued commitment to advancing sustainability and innovation in the India's textile sector, and deeply appreciated, Madam, and we are honored by her presence today. It is a privilege for India to jointly host these sessions with the Ministry of Textile on circular economy in the textile global best practices in hazardous chemicals eliminations. Why we are using the title of the elimination? Because this is the J-funded project with the Ministry of Textile, more focusing on the eliminating hazardous chemical in the textile fashion supply chain in India. We supported in 8 countries. India is one of them. We supported in Asia like India, Cambodia, Mongolia, Pakistan, and even in the Latin America and Caribbean, Trinidad, Tobago, Ecuador is a part of the country which we need to more focus on the construction and chemical. And chemicals for the India, we need to think about to work like that. India is proud to support India's sustainable textile transformations through a country's first J-funded project, and we identified the clusters which we implement to support some chemical interventions, energy interventions. Of course, UN is the mandate for the UN empowerment, so we try to think about to support gender equality. And 4th major core indicator is the land improvement. In this way, how we will try to support for the MSME unit, that is very, very important. So in this regard, I am requesting Textile Madams, Commissioner Madams to chair the sessions. And parallelly, I will request to the moderator, Mr. Arpit Bhutani from the Circular Innovations Lab. Because as you know, the circular innovation, Mr. Arpit is more focusing and more experienced in the field of circular economy, especially for the chemicals. And they are involved in the JEF projects to more supporting in the terms of chemical and energy. So I request moderators and the chairpersons, Madam, on the dais, please. With this regard, I am requesting all the panelists from JDSC, Dr. Prashad Pant, Dr. Rao from Axneri, the Chief Scientist, Dr. Raul Nabar from the IIT Mumbai, Dr. Vaishurs from the important things, yeah. Dr. Rakesh, Dr. Tapan sir from Textile Committee. So my concern for this focus of the discussion is more focusing, because we have in a parallel verticals expert, and in that way how it will help to the project, especially for the textile, that is very, very important. So in this regard, I am requesting Textile Commissioner Madam to give some address for regarding the project point of view or the panel discussions point of view. Thank you, Madam.
Thank you so much, Dr. Pankaj, and it is a proud privilege to be here to speak on the important theme of circular economy in textiles, global practices in hazardous chemical elimination. So as the global textile industry moves towards a circular economy, one thing is becoming very clear, that is, we cannot hold a truly circular textile value chain without addressing the hazardous chemicals. So chemicals used during dyeing, printing, washing, finishing can pollute water, soil and air, and they pose risks to the workers and the consumers as well. And they remain embedded in the products that eventually enter the recycling streams. So their presence undermines both the environmental sustainability and the safe recovery of the valuable textile materials. So it is very important that when we speak of the processes should be very sustainable. And we should move from a win-win to a win-win-win strategy where ecology, sociology, and economy, all of them are taken into account. So therefore, effective chemical management is not merely an environmental obligation, but it is a fundamental requirement for credible circularity. So circularity begins not when a product becomes a waste, but much earlier when we choose the raw materials, when we choose what would be the entire production process and the way we start of conceiving the product. So globally, several best practices are guiding this transition. Initiatives such as the ZDHC program, the European Union's REACH regulation, and the certification systems such as Blue Sign and Ecotex are helping manufacturers eliminate these hazardous substances and improve the waste water management. पहले हम लोग chemicals उसमें डालते हैं, फिर chemicals को हटाने के लिए और पानी और air और energy को waste करते हैं. So when we conceive any innovation, any product, at that time itself, if we take these things into account, I think we will conserve lot of money, energy, and time. So the cleaner production is also a good business, and it can reduce the chemical and water consumption, lower the treatment costs, improve worker safety, enhance the product quality, and also it will be a step towards recycling also. So technologies such as low impact dyes, bio-based processing, digital printing, water efficient dyeing systems. We also have a speaker who have developed waterless dyeing. So it would be very interesting to also hear all our panelists here who are already working on it, and the AI-enabled chemical management tools for making this transition more practical as well as environmental friendly. So the Ministry of Textiles is committed to support this transformation through initiatives such as PM Mitra Parks and the proposed Tex Eco initiative, which will focus on circularity, certification, making the production process more cleaner, traceability, and also we would be giving support to the MSMEs to move towards cleaner production. So by embracing safe chemistry, India can protect its environment, strengthen the buyer confidence, improve resource efficiency. As we all know, today the India-UK FTA has kicked in, and a lot of FTAs, India has done a lot of FTAs. So now with more of exports, these certifications, regulations are no more, only words. You have to embed them in your business strategy. As one speaker said yesterday, ki sasta version of sustainability won't work. So sustainability does come at a cost, but if you see, it is the best way we can use our resources. So it is the most efficient way, rather than thinking in that way ki zyada paisa lag raha hai, we have to shift our attitude, shift the way we see things, and see that we are making the most of everything. So I really look forward to all the panelists. I have one more session soon at 2:30 or 2:45, so I would be leaving, but I would take all the points from Dr. Pankaj because I don't want to miss out on them. Thank you so much.
Thank you, ma'am. Because it is very, very important to cover all the aspects which is more relevant to the chemicals, because ma'am is completely more focus on, if you are using something, we'll try to think about to invest and energy both. So how we will try to say something as to reduce the cost of the investment before going to look for some intervention and innovations. In this regard, and I'm requesting Arpit to, because it is very important, because we have very limited times, and the export is more in traction interventions with the respect of chemicals. I request Arpit to take care of all the things, and you can go ahead. Thank you.
Thank you, madam, and thank you, Dr. Pankaj. Good afternoon, everyone. It's a pleasure to be moderating this session again. I was there last year as well, and thank you to Dr. Pankaj. This panel brings together the expertise this JEF project actually depends upon, that is spanning verification, chemical management, academia, effluent science, government, and cleaner production technology. Let's get started by introducing our wonderful, wonderful panel. Mr. Rakesh Vazirani, Director for Decarbonization and Cleaner Production at Bureau Veritas, verifying sustainability performance across global supply chains. Dr. Prasad Pant, Chief Technical and Education Officer at ZDHC Foundation, responsible for development of all guidelines and frameworks for ZDHC program. Professor Dr. Rahul Nabar, Professor of Chemical Engineering at IIT Bombay, specializing in process design, chemical regulation, and industrial safety. Dr. Nageshwar Rao Neti, former Chief Scientist at CSIR NEERI with 30 plus years expertise in industrial wastewater treatment. Dr. Tapan K. Raut, Director at Textile Committee, Ministry of Textiles, working at the interface of quality standards, testing infrastructure, and sustainability compliance. And Dr. Swapnesh Ubeser, Managing Director of Devon Supercritical, actually the same company that madam was mentioning, that they pioneered waterless dyeing systems. To start with, my first question is for Mr. Vazirani from Bureau Veritas. Sir, you sit at the verification layer of the whole circular economy landscape on chemicals and textiles, and you're the one confirming whether the improvements are real. As this JEF project pushes cleaner production down into hundreds of MSME units, is the sustainability data coming back getting more reliable, and where is the real gap between tier 2 and tier 3 suppliers? Would be grateful for your guidance.
Thank you, Arpit. Thank you, Dr. Pankaj Kumar, UNIDO, Madam Secretary, for this opportunity. Thank you to all of you. There are competing sessions going on, so thank you for taking the time to come here. As we start off, help me out with something, yeah? Can you just show me with your hands if you are happy with the color of the garment that you are wearing today? Are you happy with the color? And who of you enjoys the wrinkle-free, easy iron shirts here? Yeah. All of that thanks to the wonderful chemicals that exist here. Let's address the point about the kind of data. What our colleagues do is, on one hand, we go to the industry, the facilities, look at a lot of documents, verify based on some testing. So let's start with data. Last year, we conducted 1,387 environmental assessments for textile sector globally. Out of that, 25% were in India. These are from companies which are less than 100 people, so MS medium or micro. Then there is 100, 500, 1,000, 2,000, 5,000. The score, the environmental performance score of the smaller ones is 38 points out of 100. The ones of medium is already 58. Large, 78. Why you would say is, of course, they have reduced resources and hence management systems are not proper and weak. But in terms of data accuracy again, India is amongst the top tier about the data that we prepare. When we go to the big ones, the kind of data is beautiful. Beautiful, audit ready, very quick. When we go to tier 2s, sometimes tier 3s, the data seems to evaporate. And you might imagine, yeah, we are asking 21st century traceability, digital data from MSMEs who are struggling with just paperwork here. But the more contribution from policymakers or the nudge to give the direction and the infrastructure with the digital backbone that we have and the clarity of thought can move ahead. Every year, of course, it improves, performance improves. Finally, to end the chemical section, companies focus on energy, water, chemicals a lot. 70% of the companies make a plan for energy improvement. 60% of the companies make a plan for water improvement. Only 40% of the companies make a plan for chemicals improvement. Thank you.
That is a very, very valid point. And in fact, just adding on to that is that when we look at circular economy as a core, we do not focus a lot on chemicals, forgetting that we need to have safer closed loops. that is one of the major reasons that companies need to push for chemicals and circularity at its intersection. Moving to Dr. Pant. Dr. Pant, you've watched the adoption of chemicals and circularity very, very closely over the past decade across India, Bangladesh, and South Asia. What separates the manufacturers who successfully adopt safer chemical management from the ones who stall out? And as the CHEF project sets out to shift whole clusters at once, where does the Supplier to Zero program go next?
Well, as Rakesh pointed out, that when we talk about chemical management, it is the last priority. You know, people always think of energy, water when we talk about sustainability, because that is where the money counts. You know, that is where you can actually show some savings. Now, with chemicals, it is more of compliance. It is more of safety that we are looking at, and so these are more intangibles. You know, it is not possible to really quantify that, okay, through some chemical management you can save chemicals. Of course, I can give examples where you can save save costs through chemical management, but it's difficult to quantify, you know, and that is why it takes the last seat. And in my experience, I have seen that it is always a push that is required to do this, and even ZDHC, even an initiative like ZDHC, or even other certifications, they come at the push that brands do, you know, or maybe regulations do. You know, so sometimes there are regulations which do the push, and a lot of it is through the brands. And I have also seen maybe in countries like Bangladesh, where there is a huge amount of dependency on exports, and where the buyers' demands are like, you know, whatever they wish is fulfilled. There is a greater adoption of programs like ZDHC than in our own country, in India, where about 25-30% is exports and 70% is domestic. And I think this is changing. Of course, this is changing. People are realizing, especially the Gen Z is realizing that, you know, they don't want to only see the product, they want to see how it has been made. So that things are changing. But there is no doubt that, you know, we need more regulations, madam. We need that our Indian government, when we talk about sustainability, or I think we are also planning to come out with an eco label, we make this chemical management as the mainstream. Because I think that chemical management is like the engine under the car hood. You know, everybody looks at the car, you know, everybody sees, oh, this is a Mercedes and this is a BMW. But what drives it is the engine. And actually, when we talk about water pollution, we talk about air pollution, we talk about chemical, safety of clothes, we are actually talking about chemicals. And I think this awareness has to come more in our supply chain, more in our production factories. And that is where I think it's a challenge. And I was talking to Pankaj also, that with the CHEF project, one of the challenges is this, that why or what will motivate these clusters to adopt chemical management? I think that is a question that we will have to answer.
Thank you, Dr. Pant. And in fact, when I started my work in chemicals and circular economy as well, that's when I realized that how chemicals actually touch us at every point in our lives and on a daily basis. And thank you, Dr. Pant, for also addressing that we need, I think you said, I can infer it that you said a little bit of a carrot and stick approach to move forward, maybe a little bit more carrot in terms of brand push. Moving to Professor Nabar from IIT. Sir, from the chemistry itself, of the thousands of chemicals still running through India's textile supply chain, which many of them are hazardous, which are the ones we most urgently need to design out? And since so much of that manufacturing sits in MSMEs, this CHEF project is built around, what is a realistic pathway for that?
Yeah, thanks. So I think it's all about priorities, right? I mean, if you look at a typical MRSL, there is so many chemicals listed on it, right? If I told everyone, you know, eliminate everything, right? So that's not going to work. Now, so how do you look at it? So I could give you specific examples, phthalates, heavy metals, PFAS, for example. But I think the framework is important. So one of the things is we need an inventory of, one is quantity, right? Where are the major problems in terms of tonnages? What are the largest tonnage chemicals? Second is what is the severity of the problem, right? So not all hazardous chemicals, I mean, per se, caustic soda is hazardous, right? But that's very different from some other hazards. So the second is what is the hazard level? And third is how difficult is it to eliminate them, right? And often all these perspectives come from different people, right? And so one thing I would caution is rules have to be made, but there has to be always a techno-economic evaluation, right? So you want to eliminate the hazardous chemicals, but be very careful. You don't want to eliminate the industry, right? And I work with a lot of MSME guys, and one of the things which is happening is compliance is becoming very onerous, right? And so we need compliance, we need to eliminate the hazards, but it should not become pile after pile of papers where you're ticking the boxes, right? And I see this and I empathize with a lot of the industrial guys. The number of certifications out there, we need a lot more harmonization. We need easier procedures, right? And that needs everybody to come together. And so from the MSME viewpoint, a lot of it has become very reactive, right? So one set of people make the regulations, it gets out, then people figure out it's very hard to comply. So I think we need, rather than presentations, I mean, we need more talks, etc., where people are on the same page, right? And when you say eliminate this, you have to give them a realistic option, because if that's not there, then people are either going to entirely ignore the certification or it gets pushed, right? So it's not a question of just having a stick, but often having a realistic approach. And the last thing I would say probably is things like PFAS, for example, right? The world is talking about PFAS. My personal opinion is, of course, PFAS is bad, but sometimes there is a disproportionate focus on certain areas, right? They need a focus, but you go to a waterway and you think about a PFAS limit which is parts per trillion, and then you see the actual quality, and we are struggling with things like BOD, right? So, so approaches have to be rational and realistic. I think tackle the hardest problems first, then go down, and it has to be, if you look at a waterway in Denmark versus a waterway at an industrial cluster in India, the problem is very different, right? So we need to learn from global regulations, but also take a more realistic approach so that we support MSMEs and, so I empathize both sides of the problem. We need to regulate it, but at the same time, we need that sector to survive. And I think it's a very difficult balancing act, but I'm optimistic that projects like the JEF one will, make inroads there.
Right. Thank you, sir. And the JEF project in itself pushes a lot for also finance. How to finance this transition, which is very difficult. Whenever we looked at hazardous chemicals, we also look at substitution. And one example is that one project we are doing on mercury and skin lightening creams. Mercury is not needed. Skin lightening. It's a UNEP project, and we were asked to figure out whether do we need another substitute chemical for it. No, we do not. We do not need skin lightening creams. Sometimes instead of focusing on just a substitution, we don't need that product category itself. So this is something also that we can look at in terms of regulation. Dr. Rao, coming to you. The science that you've spent your career on, from advanced oxidation to zero liquid discharge, as this JEF project sets out to cut pollution load across clusters like Tirupur, Surat and Panipat, is our effluent treatment infrastructure really keeping pace? Thank you.
Yeah.
Thank you.
See, Dr. Arpit has posed a question to me that relates to effluent treatment infrastructure. Existing infrastructure, before I say that it is adequate or insufficient, I would like to draw your attention to some of the facts we are talking about. Like Dr. Rahul Navar has mentioned that some of these chemicals are hazardous. These chemicals, which we are talking of, they are not the normal regular chemicals. They have very strong bonds of carbon and halogens, particularly carbon fluorine, carbon bromine, carbon chlorine, etc. Now, the bond strength of this, carbon fluorine, carbon chlorine, carbon bromine bonds are much stronger. And normally, the microbiologically produced enzymes do not have a mechanism to provide sufficient energy to break down those bonds. Now, considering that such chemicals are being used in the textile manufacturing process, and some of them are entering the waste streams, liquid streams, let us believe now the wastewater reaching the effluent treatment plant contains some of those hard to degrade chemicals. Now, traditionally and conventionally, we design our effluent treatment plants to handle bulk parameters like chemical oxygen demand, COD, biochemical oxygen demand, and some suspended solids, etc., etc. The routine way of handling is to provide a primary treatment to remove the suspended solids, secondary treatment to oxidize the oxidizable organic compounds, biochemically, microbiologically you can oxidize it. Now moving next, you can have a tertiary treatment if it is desirable in the industry. Now such a microbiological primary, secondary, tertiary treatment systems, they are not originally designed for treating such hard to treat chemicals, which are the, say, very strongly bonded atoms are there. So the microbes cannot break them down, therefore they enter into the discharged effluent. From that viewpoint, the existing infrastructure of effluent treatment plant is falling short of capabilities required for that. Now we also have as a requirement imposed by CPCB or state pollution control boards, we have zero liquid discharge treatment systems. There we use thermal methods to concentrate the effluents as much as possible and recover the condensate water for reuse purpose. Let us understand that such condensation processes also carry some volatile organic compounds into the condensate. And therefore, you will have condensate which has some contamination with the volatile organic compounds, particularly ammonia-like compounds. And we also have salts to be recovered from the concentrate. That is also again a thermal process which is activated thin film dryers they use to recover the salt in the solid form. So these chemicals which have not undergone any change during the effluent treatment plant, they are now partitioned into solid. Now such a system where the chemicals are easily passing through, do not undergo significant destruction during the effluent treatment plant, they ought to go into soil. Wherever you use the salts, reuse or dispose of in the landfill, all these chemicals find way into such landfill areas. So from that sense, I am almost liking to say that the effluent infrastructure with respect to treatment of such chemicals is inadequate. Okay, that is my first answer. And also, I am also willing to acknowledge that industries on their own taking initiative to reduce the chemical consumption. I had the opportunity to work for UNIDO on the CEOED document for this elimination of hazardous chemicals for textile supply chains. We have studied across 8 sectors in India, and we found that the chemical consumption in 2024 was half of global average, which means that the industry is picking up the call. For whatever reason they are doing it, they are reducing the chemical use now. Now, whether the PFAS-like compounds are being reduced or not, we do not know. We have an idea, data, which suggested that there is substantial reduction already taking place. Maybe concerted efforts from government and other policy holders can push it further and reduce it further. Okay. That's my answer.
Thank you, Dr. Rao. And I had the pleasure of recently visiting 2 effluent treatment plants, one in Okla, and it fell short of the CPCB parameters. So when I had a discussion with them, they said that because they don't even know what kind of chemicals are being passed on from the industry. So they need to have the clear stock taking exercise has to be done, what chemicals are there that is given to them, what kind of discharge is given to them. They don't know the exact, so the technology cannot be adopted unless they have that information. As the second effluent treatment plant, which is Mohan Cooperative Industrial Estate in Delhi, that did not exist. That was only on paper, so it was a closed building in itself. Moving to Dr. Rawat from the ministry's vantage point. Sir, you are the executing partner for this JEF project, and you have a clear line of sight on what the sector actually needs. To eliminate hazardous chemicals at this scale, which is very difficult, what's the missing enabling infrastructure, and how can the JEF project really move that needle?
Thank you very much, Mr. Arpit. Good afternoon to all. So in fact, you know that the textile sector mostly is cluster based, and about 90-95% production is coming from MSMEs only. So you can't imagine, we can't imagine the interventions without thinking about MSMEs and clusters. So JEF UNIDO project in fact envisages to go back to the clusters and reach out to the MSMEs to help them, to support them in achieving certain defined parameters so far as elimination of hazardous chemicals are concerned, and also in effectively achieving the sustainability in the process of manufacturing. As you know that in the JEF project that we are talking about, many 5 important parameters. One of them is the elimination of hazardous chemicals. We are talking about 9 Rs so that industry can practice. We are talking about inclusive growth by adopting new technologies, sustainable technologies which help them to in fact achieve maybe minimal use of chemicals in addition to elimination of the hazardous chemicals. We are talking about how MSMEs can also share the certification mechanisms, maybe the process or production technologies through common facility centers, so that the cost effectiveness in the process can also be adopted or achieved, so that the industry can maintain the effectiveness. Coming to the gap in certification mechanisms or testing and certification mechanisms, as you know that I belong to Textile Committee, we have about 18 state-of-art textile labs across the clusters across the country. Those who are providing testing facilities, conformity assessment facilities to the MSMEs and industries. But I feel that we do have a mechanism, or we do have infrastructures, but the gap is that we need to in fact create a network of the certifying, the network of all the institutions, organizations who are providing the certificates to the MSMEs, to those who are providing the service to the MSMEs. Because most of the times we find it that our 18 labs is not sufficient to provide services to all MSMEs. So they are what we are envisaging here, that we can have some sorts of mechanism which could help in fact to reach out each and every MSMEs to in fact enjoy or to avail these services at a minimal cost. So that is one of the factors that one of the issue that we are trying to address in the process. And I feel that this is a unique project where we are talking about some interventions which will help our MSMEs in a big way to achieve the elimination of, or achieving adopting the technologies, new technologies which help them to eliminate the use of hazardous chemicals. At the same time, to rationalize the cost which can also, in fact, help in achieving the competitiveness in the long run. Thank you.
Thank you, Dr. Rawat, for giving a viewpoint from the Textile Committee's perspective on how to move this transition, and also what the JEF project will actually be looking at. Moving to Dr. Baser from the private sector, we always talk about private sector, and thank you for being here with us. Please tell us what is supercritical carbon dioxide dyeing waterless technology, and it's super interesting to understand how does it work and how far it can go realistically in the Indian context.
Yeah, thank you and good afternoon. I'm really thankful for inviting in the panel. Basically, we have a technology which is primarily a waterless dyeing technology for textiles, but it is quite a differentiator as compared to other technologies available in the world. I am happy to say that it's a internationally patented technology. We got a patent in Europe, we got a patent in the US and then in India, where in fact I'm so happy about this discussion because this is what has been bothering me, that any sustainable report you take up, they only talk about how much water is saved and how much energy is saved. And then at the end they'll say, because they have converted things to solar energy, they have converted to wind energy, we are all fine. Then they are saying we are having zero liquid discharge program, so we are fine. So nobody used to talk about chemicals at all. This is the first panel where people are actually worried about chemicals. So this is a very nice thing that any regulation which is coming up has to, now with this digital passport idea coming up, I'm sure this will actually get enhanced, and the consumers will know exact picture about what kind of degradation of the environment has happened at the manufacturing stage. So when Dr. Pant was saying that it's difficult to monetize, but actually my view is slightly different, that chemicals are bought. The cost of the chemical, like we discussed that salt, maybe it's cheap, but the cost of zero liquid discharge, when you're buying the reverse osmosis membranes and the energy required for evaporation. So when you do the costing, it should involve right from scouring to dyeing and finishing to washing and then zero liquid discharge. That if you see, with our process, we are saving 95% of chemicals. When we do dyeing of polyester cotton blend, we can do it in single step in 2 hours, and we are not using any salt, no reduction clearing required. So totally we are saving 95% of chemicals by weight. But when you actually do the whole calculation up to zero liquid discharge, it becomes around 2.5% cheaper, considering the cost of chemicals, cost of water, cost of energy. We are saving 75% of water, 67% energy, and then the zero liquid discharge energy and cost. So when you actually are going to look at the total picture, then it will not be more expensive. Like for example, today we are pushing for recycled material, which in all fairness may be slightly more expensive as compared to virgin material because of the energy and the process which is required to convert the waste into useful product. But if we combine recycled product with a sustainable scouring process, then sustainable dyeing and finishing process like ours, and then sustainable washing process, I'm sure we will actually get a complete synergistic improvement in the sustainability, and the final product will not be more expensive because we have saved water, energy and chemicals at every stage. And that I think would be the answer. And this project of UNIDO, Dr. Pankaj, we have been discussing, that this can be extended to MSME. And India is the only country, I would say, where the government believes that the textile industry can increase the GDP, it will have more employment avenues, and there are a lot of Tex Eco initiative teams. Everywhere there is a lot of money getting assigned, which needs to be used properly. And I think India can really shine in the sustainability field with the selection of the correct technologies.
Thank you, Dr. Besar, and we must really applaud the innovation, and we must applaud our innovators. So I'd request everyone for a brief round of applause for the technology itself. Moving to Professor Nabar. Sir, beyond regulation and technical training, what role should academic institutions like IIT play in actually developing and scaling safer chemistry alternatives for the Indian market in the textile sector?
Yeah, so I think there is a lot of scope, and especially looking at a sector like this where there's a lot of MSMEs. Let me start with the fact that regulations are evolving so fast that in general it's very difficult for any individual company to keep track of things, right? And I think we need to develop forums more, instead of the regular presentation model, we need more of roundtables where typically when I go to an event, it's either there is an academic event with a lot of professors or there is an industrial event with a lot of industry guys. You need more places where policymakers, financiers, academics and industry come together, right? So because whenever there is a challenge, although it's a textile sector challenge, a lot of the solutions, take supercritical, there is a lot of high pressure processes, the engineering challenges, or there may be an organic chemist involved in elimination, right? So this is a multidisciplinary setup. Places like IIT have a lot of, I think, great colleagues, but we need more forums where the actual problems are coming, we have a realistic discussion. Sometimes when there is a fantastic technology, I sense that the industry doesn't move because nobody wants to take that first risk. And that's where risk capital has to come in from UNIDO, from the ministry, from places like that. Sometimes it's a matter of capex, right? And so the discussion has to go from just purely the technical to more facilitation and techno-economic. So one of the challenges I see is, suppose you write a grant and say, hey, I'm going to eliminate, I have an alternative for PFAS, give me funds for a 3-year research project, right? There's a lot of avenues you do. But suppose you want to say, I'm going to interpret the regulations and have something for outreach, right? Not a lot of projects of this kind, but I think these are sorely needed, because if you see the ground reality, what is happening is we keep making more and more stringent rules, right? But actually making reasonable rules and enforcing them, and the people on the industrial ground, they are lost in the day-to-day realities, right? It's difficult running a setup. So how do you do that hand-holding? And things like AI have a huge potential to revolutionize. Suppose you have a formulation, you could optimize it and eliminate some of the hazardous substances out there. And in the past, it would be very difficult, right? Because you would need the right access, the right people and things like that. Now, AI makes it easy. I can even imagine that you develop a custom LLM technically for regulations, right? And so it's not rocket science, you can do it, but I don't think it's very realistic to expect a small MSME to do that. Right. So how do you pool resources of these kind and then upgrade the field? One of the things is MSMEs need top talent, and with the way LLMs are going, I think a lot of talent from say IIT or other places is available for core sectors. And a large company, when you compete, they have economies of scale, they have other advantages. So for an MSME, the real advantage is only the quality of people it has. And so I think these are areas in which we should figure out how do we get better talent, how do we have joint projects, right? We have some projects at IIT where students work on industrial problems, right? We need more of these and the MSME guys to come up. It's not really a large cost incentive. It's a matter, it's a leap of faith. If you've never done it before, now you need to engage and start doing it, right? So I think, yeah, we have to do more practical things where it's not just a research publication where costs are not mentioned and that doesn't lead to anything. We have to have that touch with ground reality. So I think these are some ways in which IITs and the other top institutes can indeed contribute.
Right. Thank you. Thank you, Professor Nabar. And coming from Copenhagen, there is a mandate by the government of Copenhagen that every university has to have certain number of industrial postdocs, industrial PhDs, and even industrial internships focusing only on real problems and not creating documents and documents. So there is a 30% mandate by the government of Denmark for every university that is state funded. So something like that could be very interesting for Indian context. Also, Dr. Pant, moving to you, with parallel frameworks like ZDHC, Oecotex, GOTS, there's so many others, and Professor Nabar also talked about harmonization and equivalence. Does having multiple systems actually serve different purposes, and how can they consolidate and how can we solve the problem together with these multiple systems?
No, there's no doubt that we need to harmonize, we need to have a common standard, as we say. And the objective of ZDHC was in fact that, so we are, for the last decade when we were born, or since the last decade, we have been trying to harmonize different certification standards and bringing them all together. And the classic example of this is our MRSL, the Manufacturing Restricted Substances List. Because when ZDHC was born, the whole paradigm shift happened towards input chemical management. So rather than, as Dr. Rao said, trying to treat at the end of pipe, the idea of ZDHC is why don't we control at the beginning, why don't we control the input chemicals themselves? And hence the MRSL was born where the chemical industry was made responsible to ensure that these hazardous ingredients were not put in their formulation. Now, as soon as we came out with the MRSL, a lot of others started, and there is I think those who understand Hindi, there was an ad, कि भला उसकी कमीज मेरे कमीज से सफेद कैसे, So every brand started making that same MRSL stricter, and certifications also today have more or less the same list of substances, but they will claim that this is my MRSL. So we have been trying to do that, and it's a difficult task, because I always counter this question with another question, that can we have one single language in the entire world? Or can we have one single religion in the entire world? Will that religion satisfy all aspirations of different people? Maybe, maybe not, because still every population, every kind of society has their own aspirations. So similarly, every brand has different materials, they have different audiences to cater to, or different countries in which they sell. So maybe, there could be slight deviations to a standard, but yes, definitely, if there is one standard, it can reduce duplication, it can simplify things, as Dr. Naba said. Things are moving in this direction, because if you see now, and I don't know how many in the audience know about it, but there is a EU regulation which has come, which is a CSRD, which is Corporate Sustainability Reporting Directive. And the other one which is coming is the CSDDD, which is Corporate Sustainability Due Diligence Directive. Due diligence means the brands will have to make due diligence of their supply chain, whether they are in Europe or not, and report this in their corporate sustainability. And all this is leading to harmonization. All this is leading to, sort of aggregating all these different requirements into a single kind of a standard. And I hope that this will be effective as early as possible.
Thank you, sir. And it's again much needed in terms of the push that you said in your previous comment, also push from the regulation that is there. Mr. Vazirani, let me bring it back to you from the verification side. So decarbonization and hazardous chemicals elimination often gets treated as separate agendas by manufacturers, sometimes even policymakers. One is about emission, other is about compliance. Should factories be tackling these together or separately, or how should we do it?
I cannot oppose what were the opening remarks of our textile commissioner. When she shared the connection between chemical, water use, energy, and energy required in treatment, we heard the same from Dr. Basar, where he said, well, look at it holistically. So surely not. It's all input materials. Energy is input, just like human resource, just like other material, chemicals as well. There are standards out there now for material flow cost accounting. You mentioned, Dr. Basar, this is the first time you are part of a panel where we're talking of chemical together with energy and water. Well, in our neighborhood in Bangladesh, they've been looking at this for 2 years. And 2 months back, they came up with the first dissemination workshop on the nexus between chemicals, water, energy. And there are practices out there, documented business cases, yeah? I'm curious, who of you are looking at saving cost, operational cost, by resource efficiency? Are there any in the room? Yeah. So, especially for that purpose, looking at it from the cost perspective, when we talk with MSMEs on capacity building, they hear, oh, one more agenda, yeah? First you came here with the agenda of energy saving. And I have some team members and budget. Then you came with the agenda on water, and I have team members. And now you're coming with the third agenda. So GIZ hired a psychologist, and they said, you know what? The new agenda is the resource efficiency agenda. It's all together, come up with one team planning, one kind of capex measurement, which addresses all. So surely not, yeah, they are intertwined in the bucket of materials.
Thank you. Thank you, sir. Dr. Rao, coming back to you again. Is there a role in this transition on nature-based or biological treatment approaches closer to India's traditional knowledge systems? And in fact, I always say that we always look towards the West. We can also look towards our traditional knowledge systems, which are always very sustainable, working alongside the newer technologies like advanced oxidation and ZLD technologies. Could you please guide us around that a bit?
Yeah. So, if we talk of traditional knowledge, let's say soil is one of the natural systems available for us. So there are people who have developed, including IIT Bombay, NEERI, we have developed technologies based on soil sciences. Soil bacteria are exploited to do some kind of treatment, so which can be referred to as something like natural biological systems to treat some effluents. But they are intrinsically slow processes, and they perhaps cannot address the large volumes of wastewater we are discharging, and the kind of land requirement is very high for treatment systems to develop based on the natural biological systems. On the other hand, we have advanced oxidation technologies which actually work on generating in situ oxidants in the wastewater itself, like hydrodynamic cavitation, which we have developed and we have installed in Nandiseri industrial sector, which is a chemical sector. And it has been installed as pre-treatment system and post-treatment systems also, and at the common effluent treatment plant system. The efficiency is very high. Prior to this technology, the industry was using a conventional biological treatment system, but they very well know that that never worked for treating the BOD of the effluent. But then to comply with the CTP and STP norms, regulations, they had to go with the technology until we joined them and changed the scenario there. And a complete non-biological CETP has been developed there in Nandiseri to address the chemicals. Some of them are dye manufacturers, textile chemical manufacturers. The systems can actually advance the treatment methodologies in the effluent treatment sector, particularly for textile also. And more than, say, 300 to 400 industries in that Gujarat area, they have adopted this technology, hydrodynamic cavitation. We also had developed electro-oxidation technology, but it's a little bit more expensive. I would say these technologies, they can play a great role in the industries which are lined up along the coastal areas, where they have a permit to discharge effluents into the sea. Whereas in the landlocked areas, ZLD is the only option they have. So they have to adopt ZLD, but ZLD is not any well-defined package of technologies. It is dependent again on the effluent quality, effluent quantity, and then the number of unit operations you want to install. If you want to control capex, you have to reduce the unit operations, and the aim in the ZLD is to start with as small effluent quantity as possible, so that you can have control on the capex and also on the OPEX. So ZLD is choice of the industry. CPCB never says have these units for your ZLD. It is up to the industrialist to choose from the basket of unit operations available and set them up and get the result finally. But ZLD is not a complete solution. You may recover greater than 90-95% of water and reuse it, but they have a headache of salts accumulated. And those salts are not clean salts, they are mixed salts. As I said, some of the toxic constituents, they actually accumulate into salts and result into effluent again once the salt is dissolved. So these systems, they cannot be compared on a single platform, Their purposes are different. Their what you call application is different. So therefore, they have their role. But talking in favor of natural biological systems, I would say they are very good for handling legacy pollutants like PFOS and other things if you are handling. Combined with activated carbon, a natural biological system can work much better to contain the continued pollution of such toxic chemicals in the water. This is very important because these pollutants can potentially contaminate groundwater if they are left unattended. And they can also contaminate drinking water sources. Already the research, the analytical results available across India indicate substantial surface water pollution using such, with those chemicals, PFOS, PFOS, PBDs, name any of them you can find in water. Only thing is the capability to analyze them in picogram level, that is one limitation. Not all labs have that capacity, but you can find if you have the capacity of testing at it. The important thing is sampling of water for testing such chemicals. There you need actually sampling technologies. And if you want to sample, say, one PFOS compound or something like that, such compounds which are typically hydrophobic, you have to use passive sampling. You have to leave the sampler in the stream of effluent or water body over a period of a month or so. Continuously water flows over that and the pollutants gradually get accumulated onto the passive sampler, then extract from that sampler and go for testing. So the technologies which we are talking of, they are very intricate for addressing the bulk pollutants, not the specific pollutions like this. So for polishing treatment, NBS systems, natural biological systems. For rapid and result-oriented effluent treatment, go for AOPs. For water recovery, go for ZLD. This is my...
Thank you, Dr. Rao, and we have so much to learn from your wealth of experience in this. Dr. Baser, very curious to understand, you made an innovation, it is patented now. What are the challenges you're having to scale it up? What are the we have representatives from the policymakers, academia, United Nations being present. What are the challenges you have, and what you need from everyone to scale this up?
Yeah, so I'll just add to Dr. Nabar. I'm also having my roots in IIT Bombay. So when you asked what IIT Bombay has done, so the roots of this supercritical CO2 technology, I started at IIT Bombay between 93 to 97, and then I was the adjunct faculty for a small time. And so IIT has actually helped. And in that sense, actually it was a technology development mission project from Government of India, which you referred some other countries are doing. So the whole idea was that we are called Indian Institute of Technology, but there is no technology actually coming out of the institute, even in 93. So then Pranab Mukherjee was the chairman of Planning Commission, and he wanted all IITs to develop technology in food processing. Because we are farmers to the world, and actually all the hard work of the farmer doesn't get paid because we don't do value addition. So the idea was to develop technologies for value addition. Supercritical CO2 was well established in Europe for extraction of natural products and all that. So that's how we started. And then we are bootstrapped. After coming out of the IIT, then we developed all these kind of more applications and technology. So I have been saying this, that it's very easy to get awards, but difficult to get a purchase order. Okay, so that happens, but you need patience. So since 93, I have been wedded to supercritical CO2, and that kind of patience, that kind of, and we are bootstrapped, so we are putting our own stuff. But we have been lucky in a way that we got innovator association with Fashion for Good, and that exposed us to Mr. Pant, who has been a mentor for us, and so many such nice people. And then we got introduced to brands who have a major kind of initiative in this direction. And then they also had partners like Arvind Limited, Wellspun. So it's a kind of an ecosystem which actually works. And then H&M actually was very happy with our technology, so they wanted to put it in Bangladesh. But Bangladesh had some financial issues even in 2001 to 21, sorry. So Arvind said we want to do it, but then we need some brand or industry or the government to support us. Because if you produce something very good, but if the buyer doesn't appreciate, it really, is not the right thing to do. So Puneet Lalbhai is very excited about anything on the environmental thing, but then he said that doing it alone will not actually work. So then I said, like, anyway, H&M was interested and they were also supplying to H&M, so why don't you marry? And that's how this project came up with Arvind Limited. So we have a working project now at Arvind Limited on commercial scale. And so everybody says that show me one working plant, then I don't want to be the first, that. So now we are in a much better situation where it's a very successfully running plant at Arvind Limited. And we have seen this practically, whatever we actually calculated theoretically that this much saving will happen, we are actually getting better savings when we are actually having the plant at Arvind Limited. So sustainability doesn't have to be expensive, that much I can tell. Choosing the right technology at every stage, we will actually make the sustainability work without making the customer pay for it. That, I think, the savings is the key. So we need to work on savings without compromising on the final quality of the product. So because the industry, we can't tell them that, okay, some small reduction in the fastness is okay. That will not work. We have to give equal or better, but with savings, which is the requirement today. Right. So I would say that challenges have been plenty, but it is also required. And now, so what I said, what I feel is the answer is to have the conglomerate. So we need to come together right from raw material recycling people, scouring people, dyeing and finishing, and washing, finishing, everything. We need to actually, so the Fashion for Good has this project called Future Forward Factory. So our machine at Arvind Limited is the first machine of the Future Forward Factory, where they have tried to identify the good technologies at every stage. And so they have chosen our technology as one of them for the dyeing. I would say that is the answer. So we should actually have these kind of, in India, luckily we have this PM Mitra Park, a lot of money, actually huge amount of money Government of India is parking for the textile industry. It's only people like us who have to guide them properly, make sure that they are used properly. I think India is really blessed in a way for textile, I would say. And that I think we can be a sustainable hub for the world. I think that's the answer. Yeah.
Thank you, Dr. Baser. And whenever there is a discussion on circularity, be it textiles, it will never be adopted by the industry only solely on the grounds of environment. That's why circular economy, I feel, removes that economy versus environment dialogue, and it brings both of them together and create economic incentive to also push towards circularity. Moving to Dr. Raut from the government, so a recurring theme, and we have been discussing here also how MSMEs struggle sometimes and large corporates are able to still do the compliance. What do you think as a policymaker, as we can do and do hand-holding approach for MSMEs to still comply but not have that burden of compliance over them, which really breaks their back?
Thanks. That is very, very valid and very important questions. Because you know that the MSME always thinks that it is burdensome to adopt any new technology or new compliance architectures. And that is one of the reasons why most of the times the MSMEs shy away to adopting new approaches. But if we could able to support them in mitigating this activity or adverse effects, at the same time, if we could able to in fact incentivize them then they will come forward and adopt new technology, adopt new process, new method in the process of productions, and also go ahead. So here government in fact trying its level best to in fact provide hand-holding support to the MSMEs so that they can adopt the key aspects and go ahead. And in the JFA Innovative project, as you know, that we are supporting 4 big brands, in fact, for adopting the technologies for on sustainability, and also, in fact, mitigating the, or maybe rationalizing the use of chemicals. And the idea is that once it is the big houses who are in a better place to adopt this new aspects, and once they adopt it, then we can develop new case studies or best management practices, and which can be disseminated to the industries or MSMEs, and we can showcase it as a case study before them, and of course encourage them to adopt it. That is one thing. Second point is that relating to the standardizations. As you know, that adoption of standardization among the MSMEs is very less. So here government is trying to in fact build capacity of these MSMEs, and through awareness creations, through capacity trainings and capacity building programs and other different means, so that they can in fact build their capacity in the process, and go ahead and in fact adopt the international standards in the process of manufacturing, in the process of adopting sustainable technologies, and that could help us. And coming to the Textiles Committee, as you know, that beyond this MSMEs, we are also talking about developing a circular textile ecosystems, where in fact we have developed a TRF. I would request all of you to please do visit in order to in fact browse through Google and see how we have developed an innovative mechanism on textile recovery facilities. And there we are trying to in fact create a circular textile value chain, where instead of the waste or the post-consumer textiles or pre-consumer textiles going for landfills and water bodies, and we are trying to in fact rechannelize it to the value chains, so that the waste can be used as a resources and help us in fact in the developing a circular value chains. So there also we are we are trying to in fact involve the MSMEs in the process of manufacturing and developing the circular value chains, so that MSME can feel empowered, and MSME can also adopt the new technology. MSMEs can also think about these chemicals and hazardous chemicals, or mitigating the effect of chemicals, and that will be helpful in fact strengthening our textile value chains and developing a circular economic systems. Coming to our ministries, in fact, our ministry is seriously working in these areas, and we are very quickly, maybe we come out with the Texeco scheme, and as Madam has already told, then Texeco schemes, we are trying to in fact address all the issues relating to the sustainabilities and help the MSMEs in fact to adopt it and go ahead. And of course in that system we are also trying, in the scheme we are also trying to in fact link the MSMEs to the big brands, and where the supply side issues and of course the demand side issues can be addressed, and also we could able to comply to the the regulatory ecosystems being developed across the globe led by European Unions, and our textile value chain can be strengthened, our MSME can get benefit out of it. Thank you very much. I am sure, I think I could able to address your question.
Absolutely, sir. Thank you so much for giving us a breadth of the initiatives that the government is doing. And in fact, a lot of the other panelists also said that government has a lot of schemes and policies to support us, but it's for us also to take that initiative to basically utilize them. We're running out of time, but I need just one more statement, one line statement from each one of you. We'll be meeting again next year in 12 months from now. What do you think is the lowest hanging fruit that we can pluck in removing, eliminating hazardous chemicals from global supply chain, and something that we can see in the next 12 months and have another conversation on that in 2027, starting from Mr. Vazirani and then moving backwards.
I'm lost here. I'm not sure if I know the lowest hanging fruit, but I would want to say, because it depends whether you are small or medium or small and medium and so on. I would say for the small and medium, it would be to have resource efficiency data management, because then they would know. For the ones who are medium, a little large, for them to maximize the opportunity to access green finance, which is there. In Bangladesh, only 40% of green finance allocated is used. In India, I saw last figure 9% for textile sector. So I would say those two, yeah.
Yeah, thanks. So I think you cannot eliminate what you cannot measure. So I think lay out what the ground reality is, and you will not be able to eliminate anything if you don't prioritize. So those are my wish lists. Like in a year, we should know what the baseline is and what are the top 4 or 5 that we need to eliminate and how are we doing on it.
I would say that basically, as we all discussed, that nobody wants to be the first person to use any new innovation. So luckily, Government of India has PM Mitra Park. They have a lot of schemes for the clusters, and there's a lot of money kept aside for common facilities. So I would suggest that in that common facility, apart from only ZLD and waste management, we should actually encourage any sustainable technology setup for scouring, for dyeing, finishing, and for other aspects. So if you have a profit-making unit in the common facility where people can bring their textiles, get it processed, so that they'll have their first-hand experience about the work of that sustainable technology, they will get encouraged to adopt it in their own setup. That will really, and that is low-hanging because already a lot of money is there. It just needs to be prioritized. Thank you.
Thank you. Dr. Pant.
Yeah, since we are talking about elimination of hazardous chemicals, I think one of the low-hanging fruits could be that the Government of India comes out with a regulation on very, very specific restrictions of certain chemicals in the consumer goods, in the consumer garments or the clothing. I think if we can do that, it will be the push that is required, for the whole supply chain to start understanding and start eliminating these substances.
Thank you, Dr. Pant.
No, for me, the issue is more complex. The deadline you are saying 12 months or so, you may not realize a significant transformation in this mindset of the people. The worry is about fast fashion. The fast fashion is actually putting more demand into picture. Once you ask for more fabrics, more chemicals are necessarily brought into production, so more chemical this thing. So this, I don't know how to really manage this supply demand or extent of chemical use versus the demand. That is my worry.
Right. Dr. Rawat.
Again, from government side, I think that the long-hanging fruit is making use of the government scheme to achieve the desired objectives. And coming to the value chains and with respect to hazardous chemicals, what I feel personally that it is the processing units which hold the key. So I think if we could able to in fact empower the processing units, but the processing industries in fact in the process of adoption and standardizations, and that could in fact help a lot, and that could be a big game changer. Thank you.
Thank you, Dr. Rawat. I'll then give the floor to Dr. Pankaj to give a brief, before we close the panel, a brief on the project itself. Thank you.
Thank you, Arpit. Because I'm just trying to concentrate on your feedback. It is very, very important. Of course, Dr. Bashir just mentioned the cost. It is very, very important because if we are talking for the MSME units, They are much more focusing on the investment. Of course, the technology is viable, but as in a demonstration, we need to think about how the technology will support, especially for the MSME unit. We are talking for the larger scale within the fashion house, but MSME unit, when they adapted, it is definitely reduced the chemical and energy consumptions. I give you the one example in 2010 in the solar mission, the cost of the PV is very close to 70 rupees per unit, but right now in 1.35. So if you see the technology, innovative technology, it will take time, maybe the 1 year, 2 years, and that is the way the Government of India, Ministry of Textile, and all the UN agency or the bilateral, multilateral, they are working in the demonstration project. And we will try to think about how the cost will down based on the volume will increase like that. And that is the way which we need to think, and we will try to work on the way of investment cost, investment and other things. Second point is the chemical. We are talking for energy. We are talking for the various type of energy like an energy efficiency, renewable energy, green hydrogens. But chemicals, of course, I am agree with the Dr. Pant, because as you know, chemical with respect to the social responsibility is very, very important. Either the water, if we are talking for the textile, water and chemicals is a major challenge. If we will try to think about to give it to the more solutions, definitely it will reduce greenhouse gas emissions, energy prospects. So energy and environment both are very, very important. So before going to closing the sessions, I will just thank you to all of you. Thanks to all the members. Yeah. Please, before going to closing the sessions, I will ask maybe the 1 or 2 questions you can.
Sorry for disturbing you.
No issue, please.
Yeah. Like EU had started using natural dyes to move towards sustainability in 2021 or 22. So has Indian government or any MSME people took forward this chance to move towards natural dyes rather than going for chemical dyes?
I'll quickly answer that. So there is definitely natural dyes in India also. There are many manufacturers of natural dyes, providers of natural dyes. But it is a very, very minuscule supply as of now, and of course I would caution that everything natural is not safe. I mean, I can give you many examples where natural things are not safe, but natural dyes today also involves a lot of issues, like you need to have, or the yield that you get from natural dyes is not the same as you get from synthetic dyes. So the demand for synthetic dyes is so huge that it is right now impossible that natural dyes will meet that.
Yeah, but EU had started it back in 2021.
No, natural dyes are there. I mean, in India also. I mean, there are many people who are using natural dyes. There are various limitations on that in terms of range of shades, in terms of fastness, and it is a niche market. Definitely, it's a niche market. It is something which some brands also encourage. And there are some chemical companies which have come out with, like Archroma came out with, earth colors, which were basically from the waste of the earth. So these are efforts which are always going on. But when you talk about commercially, the demand which is there, which can be met by synthetic dyes, is not possible with natural dyes. And I would not subscribe to the statement that all synthetic dyes are toxic or harmful. I mean, that is a myth, basically.
Yeah, but what I have found
to add one point, to complement one point, that that the supply of natural dyes issue, of course, it is. Second thing is that during last 1 or 2 years, maybe I think maybe few years, particularly in handloom sectors, in handcrafted textile sectors, the artisans, the weavers have started adopting natural dyes in the process of productions. Okay, obviously due to some, since they are getting a premium price, or since the government is also trying to help them, support them in adoption of natural dyes, the weavers, the artisans are now trying to in fact move away from synthetic dye to that of the natural dyes. But it does not mean that synthetic synthetic dye is not good. And again, keeping the supply side, supply of the natural dye in mind, we should say, as sir has already told, that it's very difficult to think that natural dye is a substitute or complete substitute to the synthetic dyes. It's not possible.
We can get
But
natural
we can
dyes
we
from
need to
farmers,
rationalize.
sir. We can get natural dyes from farmers. India is a very big country with a very big land, and we can take benefit out of it.
Yeah, sure. We will discuss details. Definitely, it is in a very, because the time constraint is very, very important because there is a second session which we will start. So I am very thankful to all of you. And before going to start the vote of thanks, at the outset, I extend our sincere gratitude to our Honorable Chairperson, Mr. Vrinda M. Desai, Textile Commissioner, Minister of Textile, for her gracious presence, inspiring opening remarks, and heavily chairing these important sessions. Of course, more focusing on the Government Ministry of Textiles, vision and missions, even in the scheme's point of view. Also express our deep appreciations to our moderator, Mr. Pete Bhutani, co-founder, Circular Innovations Lab. Thank you to coming because he is very, very busy, and I am very thankful to here and supporting to moderate the sessions. Very thanks to the Arpit. I would also like to sincere thanks to our panelists, Dr. Pant from the JDSC, Dr. Rao from NERI, ex-NERI director, the chief scientist is more prominent for the chemicals. And I just share you the one point, he is involved in our JEF project, basically more relevant in the chemical concern. So I'm thankful to the Dr. Rao to present here. Dr. Tapan, sir, is from the Textile Committee. He is more core indicators for the executions of the activities, which we need to more focusing on the post-use 9 hours. Of course, TRF is one of the example. Dr. Versus, which they developed such a very innovative technology. And last few weeks, even last week, I just see the performance. It is very fantastic, but still I am thinking about the cost investment because we are targeting 400 MSME units. Who will adopt the technology initially? That is the major challenge. Definitely, ANIDO is very closely to work with you and find out the way how we will try to support, not for your technology, even in any other innovative technology, which is more focusing on the chemical and the water. Dr. Rahul Nambar, I don't have any word because it is a backbone of the chemicals. Whatever we are facing some difficulty, I'm just directly speak with the Dr. Nambar, and he's politely explain all the things, what is the main, because as you know, the chemical is major concern, and JEF 8 is more focusing on the chemical and waste. This is a JEF key area. So this project sanctioned in 8 countries, India is one of them. The target for the chemical is challenge, and all the export, which is very, very important, how we will try to meet the target. The target is 10,500 toxic chemicals. It is a very huge. So without your help, it is very difficult. Without MSME unit which they involve, it is very difficult. I am very thankful to the Dr. Rakesh because he's come from the Hong Kong. Share the time. In the last moment, he shares few data because I just see the data in the Vietnam and Bangladesh and even in China. I am very thankful how it will help to the project because he is very close to work with NRDC, Ilichi, and I am very thankful to say something like that as in a chemical point of view, how it will help in India point of view. Thank you to all of you. Thanks to the media. Thank you to UN teams also. Under the One UN support, we have UNF teams also. UN Women's, because we are closely working with all the UN agencies. The objective is same, energy and environment. If we are talking for the chemical, toxic. If we are talking for the energy, GHG mission. In addition to that, UN empowerment, because women empowerment is a very, very important. We are very closely to support all the women in the textile sectors. Thank you so much. And one more request before going to start, we have some small mementos to all of you, please. Dr. Rahul Nambar.